name is Marius. I am an editor at Software and Support Media, and I would like to welcome you to this talk at the Ajax London online conference. I have the great pleasure to introduce you now to Dr. Daniel Bryant, who is a product architect at DataWire and who will be speaking on the topic, the past, present, and future of cloud-native API gateways. And before I give over to Daniel, just a little bit of information. You can use the chat in Swapcard to get help by our technical staff if there are any problems. But you can also use it just for chatting and commenting on the session. You can also ask questions via the integrated Q&A tool or via chat. If there's time, then you will answer the questions after the session. Yeah, okay, so let's start.
Thanks a lot, Marius. Let me just share my screen. Fingers crossed, that looks good. So welcome everyone. Thanks for coming along to the past, present and future of cloud native API gateways. Sorry we can't be in person, but it is what it is at the moment. So I'll do my best to make the talk lively from my home office / spare bedroom. As a kind of high level key takeaways, TLDR, I'm going to talk today about how the edge and API gateways have undergone a series of evolutions that have been driven primarily over the last 25 years by architecture and technology. I'm going to also look at adopting cloud native ways of working, microservices, Kubernetes, all that good stuff fundamentally changes the workflow we as developers have. And this is probably more so than, say, Agile and DevOps has done in the past. Finally, I'm going to look at choosing your Kubernetes API gateway. And the meta message is to choose your platform intentionally. I've worked as a consultant and now for a DataWire, Ambassador Labs, for a number of years now, and I've seen many folks migrate from the old world, on-prem, colo, to Kubernetes in the cloud, but bring the same technologies with them, the same mindset with them, and they haven't got the full benefits. So I'm going to say today, if you're moving to a cloud native way of working, think about the platform, think about the workflow. This is also roughly the structure of the talk. 10 minutes looking at the history of API gateways or edge proxies, 10 minutes looking at microservices, full stack development, full cycle development, and then 10 minutes or so looking a bit more Kubernetes specific, a few patterns and anti-patterns I've seen with folks migrating to Kubernetes and what they've done with their gateway. Very briefly, this is me at Daniel Bryant UK on most of the interwebs, Twitter, GitHub, LinkedIn, you can find me there. Love to get involved, love to chat folks. I work as a product architect, so kind of product owner at Ambassador Labs, previously called DataWire. Full disclaimer, we do have an open source API gateway called the Ambassador Gateway, built on Envoy. I'm not here to pitch you that. I'm not here to talk too much about that today. I will mention it in context of the other API gateways, but just so you know my bias up front, that's where it's at, right? I also write for InfoQ, so you can find my musings on InfoQ. You can find my stuff on Jack Center too, the New Stack, a bunch of other places. And my buddy Abraham and I wrote a book a couple of years ago, Continuous Delivery in Java. My background is very much Java, software architect, ops, and now kind of product person. Reluctant marketer even sometimes, right? So I'm going to talk about the edge today. And the edge, when I say it, is that when I talk about it, is the boundary between your data center and your users. Now, edge can mean many things to many people. Like if you're an IoT person, edge can mean sensors, mobile phones, that kind of thing at the edge. If you work in a content delivery network, the edge is points of presence, close to the user. But when we're talking about sort of data center stuff, Kubernetes type stuff, the edge is really the edge of your system, that where your users kind of first interact with your tech or the tech you've spun up in the cloud. And the thesis I started with is that the evolution of the edge has been driven by application architecture and technology over the past 25 or so years. We're going to spin back a little bit now and look through some of the evolution to ground us in what's changed and how the stack at the edge, things like CDNs, WAFs, load balancers, how they have evolved and what impact it has on us. So back in 1995, I was still in high school there, maybe showing my age a little bit, but I wasn't doing professional tech at this time. I was still learning stuff, doing a few side hustles, but I was getting into Java at this point. Like Java had just been kind of, written pretty much, and early buzzing sort of in school and college. But this was pretty much the primary architecture in the late 90s. The web was becoming a thing, of course, but we weren't really sure how we'd consume the web. Was it going to be via browser? Was it going to be something like applets? So back then, there was still a lot of debate, the client side, but the server side was monolithic type apps. J2E was very popular, database at the back end, kind of classic 2-3 tier architecture. Fronting this was hardware load balancers. People were spending lots of money. If you had a successful website, particularly in the .com boom of the late 90s, and then the bust, of course, you were deploying hardware load balancers, racking and stacking in data centers. It was the target user was very much a sysadmin. This was not a developer thing. The purpose was high availability and high scalability of your site. And it was mainly load balancing, pretty simple stuff, round robin, spin up multiple backend servers, sort of spread the load of your users' requests across those servers. And if a server broke, fell down, increased latency, hopefully you detect that and you'd remove that server and then redirect the load elsewhere. 2000s, I was at university then, at college, and this is when I was doing some stuff on the side, some coding and so forth. We were still seeing a lot of similar architectures. .NET was a big thing at the time, ASP.NET in the UK here, doing a lot of Java, very similar architecture, client, middle tier, database, that kind of stuff. But we were seeing software load balancers emerging. You guys, I find it hard to believe sometimes, but technologies like HA proxy and Nginx have been around for like 20 or so years, nearly 20 years. The beauty of this, of course, was they were cheaper, didn't have to buy expensive hardware, and they were more malleable. Engineers could very quickly change config rather than having to do various knobs and switches or log in to actual specialized hardware. The target user was still sysadmins. This was pre-DevOps. High availability, high scalability was a thing. All the same good stuff you had with hardware load balancers, health checks, all that kind of good stuff. It was all about high availability, high scalability. 2005 time, this was when Web 2.0 became a thing. Kind of seems a bit silly now in some ways, but this was a big thing. Like I staked my career on this for a while. A lot of stuff going on e-commerce. I was working for a bunch of e-commerce sites doing JavaScript and Java at the back end, bit of MySQL too. Ajax, anyone who's nodding along in the audience now, Ajax kind of perhaps showing your age, like Ajax was a big thing, asynchronous JavaScript and XML. It allowed us to dynamically update web pages. Pre-Ajax, it was all make a request, full HTML page comes back. Make a request, full HTML page comes back, render it. Ajax, you could do XML HTTP request and dynamically update the DOM, dynamically update the web page. We take it for granted these days, of course, all the frameworks we've got, but this was a big thing back in this time frame. This led to the emergence of what we're calling application delivery controllers. Before it was, one request, one response. Now it was lots of requests and smaller payloads coming back. So the TLS, SSL handshake was more of a thing. You perhaps wanted to compress like the data coming back because you were spitting a lot of images over the wire. And the ADC was somewhat of a marketing term, but I saw it a lot in big enterprises. It was all about application delivery acceleration. The target user was still very much sysadmins, but it was about SSL offload. We now say TLS offload. TLS was just becoming a thing around this time frame. A lot of caching, compression, and more advanced load balancing. You often still had kind of load balancers in the mix for these things, or the ADC integrated a load balancer with it too. F5 were doing lots of great work in the hardware space, Nginx doing lots of great work in the software space. And it's slightly interesting now that F5 have actually bought Nginx. So now they've kind of consolidated over the years. But these two at the time were kind of like chalk and cheese, right? 2010 time, this was all about the proliferation of APIs. I was doing a lot of work with Google Maps APIs at the time and Stripe and things like that as well. The interesting thing then is some sites that kind of spun up with the goal of making API marketplaces a thing. So we as developers could write APIs, we could mash them together, charge money for them. At the time, this was a kind of vision, didn't quite work out, but it led to the first generation of API gateways. Kong emerged from Mashape. Mashape was an API marketplace. Kong eventually became like a spin out from there. You saw 3Scale, you saw Apogee, all these kind of things. This was the first time that the technology at the edge was targeted at us developers as well as sysadmins. And this was a big leap at the time. It was about exposing APIs to the broader ecosystem, API management, API ecosystem, all that good stuff. There was very much a move to what we say layer 7 as well. The previous world, load balancing ADCs were focused on layer 4 in the OSI network stack. So more your kind of IPs and your ports, whereas layer 7 was targeted more at HTTP metadata. So path-based routing, HTTP header-based routing, cookie-based routing, all this kind of good stuff was becoming a big thing in this time frame. Dev portals, API lifecycle management, also a big thing, big money there. Analytics, monetization was becoming important. Around 2015, this is when I was really getting into my Java career. I was doing a lot of Ruby on Rails at the time as well. And this is when you started seeing big sites struggling a little bit with load. They built Ruby on Rails monoliths and they were having trouble scaling. Looking back now, it seems kind of obvious, but at the time, the whole microservice, mini service thing was a big, big deal. Driven by the likes of James Lewis, Martin Fowler, Sam Newman, Fred George, lots of different names out there. There's lots of innovation going on. And a pattern I was often seeing was this kind of mini-lith pattern, where folks would have like a Ruby on Rails monolith and they'd break out services, but all the traffic would go through the monolith. All the traffic would go through the mini-lith. It was effectively an API gateway. It was a router in disguise. And the snag was you wanted to update one of those services, you often had to tweak the monolith too. Change the routing, change the auth. That was kind of tricky at times. This did lead very much to the second generation of API gateways. We sort of consolidated some of the cross-cutting concerns like auth, rate limiting caching. We pulled it out of the language-specific stacks, put it in its own thing. And often, you had a well-defined edge stack in that you had maybe like a CDN, Akamai or something. You had maybe a web application firewall in the DMZ, like WAF there, sort of filtering out attackers and bad actors. And then you might have some kind of layer 4 load balancer, API gateway, and some other things there too. The key thing here is the mini-lith, the small monolith, was no longer doing the routing, no longer doing the cross-cutting concerns. The second generation of API gateway is very much targeted at the API developers still. It was less about monetization. That's not really become a thing. Dev portals are still a thing, but it was more about centralizing the cross-cutting concerns like auth and rate limiting. Lots to do with monitoring as well. And this is kind of where we're at now. Ambassador, where I work for, Contour, Glue, even Nginx native proxy, Trafic, Tyke, they're all in the mix. There's lots of innovation in this space, and there's lots of choice for you as developers as well, what to use at the edge. Moving on a little bit, so cloud native applications, like we're all loving the microservices, right? Microservices really are just the latest evolution of modularization. We saw SOA, classic service-oriented architecture. We saw some other stuff before. David Parnas famously talked about this kind of approach in the 1970s, and I'm sure folks were doing it even before then. The idea with microservices is they're bounded contexts, modules with a hard network boundary. You build them, you release them, and you operate them independently, and you can scale them independently. Now, that's the dream with microservices. Doesn't always work. Sometimes you have interactions or they're tightly coupled microservices, and there, you have to release them like sort of gated or release them together, which is somewhat of an anti-pattern or an not ideal situation, but it's the reality I've definitely seen in many consulting gigs I've done. On the back end, the app architecture is now very different. You've still got these heritage systems, these money-making systems. Yeah, if you're a company that's been around a while, you maybe got some, even some like terminal-style apps, but you've probably got some colo apps, some apps on VMs. You're bringing in some Kubernetes. Maybe you're doing some AWS Lambda function as a service. There's lots of different places now at the back end your traffic needs to get to. There's different protocols now. Back when I was doing my thing, it was HTTP 1.1. And maybe with SSL on it. Now you've got gRPC, gRPC Web, HTTP, HTTP2, WebSockets. This is great. It gives us a choice of what protocol, the best protocol to select. But it means, again, the gateway has to meet all those requirements. There's different load balancing requirements often. I see a lot of heritage apps, particularly Java EE apps, just the way they've been architected, we have to use sticky sessions. Because if you start trying to have one user load balancing over multiple instances, the state management doesn't work correctly. On the flip side, when you're doing something like function as a service, you've got to be very dynamic about your routing because a function spins up and it disappears, spins up, disappears. This is, definitely a mix and match approach is often required. There's different auth requirements. We see a lot of auth sprawl at DataWire, where folks have got sort of single sign-on here, they've got auth 0 here, Okta here, some DIY stuff here, and you've got to be careful about what services plugged into what auth solution. It's very, auth is critical. You've got to make sure you know who your users are, but it can be quite tricky as you're evolving your systems. So in summary, a sort of cloud native API gateway, for want of a better term, a modern API gateway has to have all your classic number one here, API gateway type management capabilities, auth, developer portal, metrics, all that good stuff. Also needs ADC-like management. So, timeouts, kind of resilience, caching, retries, load balancing, that kind of thing too. And you need this real-time service discovery on the back end now, because you're mixing and matching. If you've been around for a while, if you're a greenfield project, nice and easy, right? Maybe some Kubernetes and some function as a service. If you've been around a while, you've probably got a few different things at the back end, which your API gateway needs to integrate with. So this kind of leads now to microservices are an even bigger change than perhaps some of the stuff we've seen pre this. Agile mixed up our workflow a little bit. DevOps increased the responsibility across teams. Microservices, you can go independently, you can release independently, you can scale independently. And the beauty is, if you're doing it right, I think what Werner Vogel said is very true. Like, you build it, you run it. I see a lot of successful companies now having like dev teams where it's fully encapsulated. They have business aware developers or business folks in the team, QA in the team, ops in the team, and they're just going as fast as they can. They're not often, they're consuming a platform via some kind of self-service mechanism, and the services they deploy, they own in production. They're often being paged if those services go wrong. Now, I like the idea of you build it, you run it. It's not, every developer's not sort of happy with it yet, but I do like the idea of owning my code from idea to production. Just, coding some stuff and handing it off. Like, for me, I've got the most joy, most enjoyment really, when I've seen users benefit from the kind of the apps I've written. The only snag is, when I was doing my thing, like, 10 or more years ago, full stack meant I knew JavaScript, bit of Java, bit of SQL typically. Nowadays, full stack kind of means everything from like React.js, Angular, all the way down through to Terraform, Chef, you name it. There's so many things out there. It feels a little bit like you're a one-person band at times, right? And particularly if you work in a startup, which I've worked in a bunch of startups, you sometimes are doing everything. And that only scales so far, I think. You look at the bigger companies, like, I know we're not all Netflix, but I like to look at the Netflixes, look at the Googles, and take inspiration. And what they've decided is this kind of they're calling it full cycle development is the way forward. They have platform teams, and for us, this could even be Amazon or a PaaS, platform as a service type thing. But if you're a Netflix, you have platform teams that offer build tools, deployment pipelines, metrics and alerting, all self-service, all consumable via APIs, via UIs, via SDKs. And we as development teams consume those, and we just try and meet our business goals. Yeah, we're looking for probably KPIs typically, increase subscribers, maximize value here. And we don't want to be slowed down by having to write lots of Kubernetes YAML or whatever. We want to consume tools. And I've seen, it doesn't work for everyone. I always caveat that with a lot of things I do at the kind of consultant level. You have to mix and match the problems and solutions. But I've seen this work really well in all different types of companies, this notion of platform team and self-service interaction with developers. And if you haven't bumped into the Team Topologies book by a couple of buddies of mine, Matthew and Manuel, this is a fantastic book. This book codifies, I think, the best practices of needing to expose platforms as in a self-service model. If anyone's bumped into something like GitOps, I think GitOps gels very nicely with this. I haven't got time to go into lots of details on GitOps, but it's kind of emerging as a best practice in the way we interact with Kubernetes. And I think this book gives you some hints at the organizational structure you need to put together to do this kind of thing. But as I've said, this is a change in workflow. Right? So if you think back to that thesis we had up front, where the evolution of the edge is driven by application architecture and technology, I think the future, or we, I should say, as my colleagues and I have got together and chatted around this, we think the future of the edge is going to be based on workflow as much as it is application architecture and tech. Yeah. And to kind of illustrate this now, I'll point out two of the biggest challenges we've seen with Kubernetes and folks adopting Kubernetes and edge technologies. The first one is scaling edge management. Back in the day, I had my Java monolith. My team and I, we'd own this monolith. If I wanted to tweak the caching, I would tweak a library in Java, build it, ship it. If I wanted to tweak the auth, I'd change the library, change the way we call out to a third party, good to go. Sometimes, the ops team owned very much the API gateway, and sometimes I needed to update that, open a port, support a new protocol. I'd raise a ticket. Typically, the ops team would take a look, get back to me, and they would often offer SLAs, service level agreements. So if you raise a ticket, we guarantee to get back to you in 24 hours, that kind of thing. And we had to factor that into our rollout plans. If we were going to modify the gateway, we needed to get in contact with the ops team early. The challenge now is we've hoisted up all the different requirements. So it's good because they're not language specific anymore. We brought them up into the API gateway, but I as a developer still need control over those things. No longer can I recompile a Java library. Now I've got to find some way of tweaking the auth for my service here, tweaking the caching for my service here. And to add to that, there's just more things typically at the edge with a microservice system. Got your monolith, it's pretty much that's the thing. You've got some APIs in the monolith, but it's kind of one thing. I've seen a lot of companies breaking up the monolith, but they've got like 10, 20 or more services at the edge. And as that scales out even more, raising the tickets soon adds a lot of friction to the development process. The second challenge is around supporting diverse edge requirements. We have got lots of protocols now, classic JSON over HTTP, REST, all that good stuff. gRPC, I'm seeing a lot of gRPC, definitely internally, service-to-service comms, but I'm seeing a lot of gRPC at the edge for mobile comms, and I'm seeing gRPC web being increasingly adopted in the more innovative customers I chat to, like my day-to-day work at DataWire. We're seeing a lot of gRPC because folks like the binary protocol. They like the strong contracts offered by protobuf, which is the way you define the interface between the two parties. And we see a lot of WebSockets too for real-time comms, and we see raw TCP as well for various things. But the bottom line is there's just more protocols than there used to be with old technology being supported. And you want to mix and match. You want to bring in a bit of auth, bring in some retries here, but for certain transactional things, you don't want to retry them at the network level. You only want to retry them at the business level. So that adds a new dynamic. I need to choose my protocol, check that it's compatible with my requirements around retries and auth and caching, and mix and match that in my config. I see folks generally we approach this kind of at the macro level with one of three strategies. And this will hopefully make a bit more sense if I put this slide up. When folks are moving from, say, like an old world to a new Kubernetes world, I see them take, sort of broadly speaking, one of these approaches. They either deploy an additional Kubernetes API gateway, they spin up a proof of concept cluster, do some new services in there, put a gateway in there, and kind of route into that new world. I see some folks try and extend their existing API gateway. This is a very popular pattern if you built the gateway yourself. You spin up a new Kubernetes cluster, POC, and then you kind of bolt on like some config, like to synchronize between your old API gateway and this new service world in Kubernetes. And the more greenfield approaches, kind of stuff where I'm working at the moment, is deploying like the in-cluster edge stack, where you literally deploy everything in your Kubernetes cluster. Yeah, often you get WAF, load balancer, API gateway, dev portal, and if it's kind of cloud native, like a lot of the Envoy-based API gateways are, you can configure everything in Kubernetes. This is the ultimate kind of greenfield solution. There's no right or wrong in terms of patterns here. You always have to mix up your requirements with what the options are, your skills with what's available and so forth. But these are broadly speaking three strategies I see. We've got a white paper on the DataWire website, or the Ambassador website. You can go into more details. In the next, I've got like 10 minutes or so now, I'll just quickly run through each of these three strategies and sort of briefly explain how they work and highlight some of the advantages and some of the drawbacks I've seen with doing these things. So the first one, deploying an additional API, a Kubernetes API gateway. This is nice and easy. You spin up your proof of concept Kubernetes cluster. You find a nice new shiny API gateway. You put that in your cluster, and you kind of just redirect traffic from your old world, into the new world. So the old world is completely as is, but you put some kind of rule in your existing API gateway saying anything on this path, anything on this IP, anything on this domain name, that's new stuff. That should be routed to this new world. You do have, of course, two load balancers in the mix, or two API gateways in the mix, but we'll come on to that in a second. I also see some other approaches where they're doing it at the layer 4 load balancer level. So they're kind of, and there's two gateways, but they don't interact. They split basically on, say, subdomains. So, x.hello.com goes here and y.hello.com goes here. I see some folks when they're spinning up new business domains, new applications, they do it on a subdomain. So you can kind of do that at the IP level. That's another alternative there. Pros, sort of good things, is minimal change to the edge infrastructure. Your existing stuff works as is. You're bolting on something new to the side. Incremental migration is easy. I see this pattern used quite a lot when folks are migrating from their old world, bundling up the microservices into containers, bringing them into Kubernetes, and this allows that incremental approach. The cons, though, is there's increased management overhead of working with two gateways. We had a couple of gnarly debug sessions at DataWire where we couldn't get security working in the new world with the customer. And what it turned out is the existing API gateway was expecting to do all the security. And it was, even though it wasn't, it was stripping out all the necessary headers and metadata so that when it got to our API gateway, we couldn't do the auth. And of course, it was quite a complicated stack of firewalls and load balancers and API gateways. It was debugging where the problem was in that stack was pretty gnarly. It was quite hard to do. So that's just something to watch. And it is also challenging to expose the functionality to each independent team in that sometimes you just have to do stuff in the existing API gateway. You've got to do it before it gets to your new gateway. So you have to sync with the ops team. And again, as long as you're raising tickets or coordinating it, you can have some kind of SLA, but there is a kind of increased management overhead there. Again, good and bad with this pattern. Not saying one's right or wrong, but these are the broad brushstrokes, problems, and good things I've seen. With extending your existing API gateway, I've seen folks do this when they've built their own gateway. I see quite a few Spring Cloud gateways. I've seen a few Go-based gateways of late, people writing gateways in Go. And I've also seen it with F5 and Citrix, where they have their existing API gateway. And what they do is they deploy a new Kubernetes cluster. They deploy an operator, like it's basically an automated application, it's like a codifying a human operator to do things that sits in the cluster. And you put annotations on your Kubernetes config. So when you deploy a service, you say, expose this service on this route with this config. The operator in the cluster is watching for that deployment. And when you do a deployment and service, it says, oh, new config here. And then it calls out of bounds on the cluster to the API gateway to make the required changes. So the operator is like the adapter there. It looks into the new world, it's sitting in the new world, it recognizes config changes, it calls out using the existing SDK, the existing API of the API gateway. And that's how you get your synchronization. The pros, the good things again, you can reuse your tried and trusted API gateway. Again, if you're an enterprise, longer migration path, this is a good thing, right? And you can leverage your existing on-premise infra. If you've got hardware firewalls, DMZ set up, this is no probs. Yeah, you're kind of bolting on the new world and just synchronizing the new world with the existing tech. The cons is that it's tricky sometimes to maintain a single source of truth. We had a couple of customers we're working with where dev teams were falling over each other because the old world was setting up new routes that were conflicting with the new world, and they were doing config that kind of had to be mashed together in a non-automated way, which was not optimal. Yeah, we could work around it totally, but it did cause a bit of confusion at the time. And we do find with things like F5 and Citrix, they've done a fantastic job, but there's not all of the functionality of the API gateway exposed in the Kubernetes annotations. We wanted to do a few things. I think it was with auth, and there simply wasn't an annotation in the Kubernetes world. So we had to go out of bounds and chat to the ops team and say, hey, we want this service with this auth. We can't make it happen with Kubernetes YAML. Can you configure the gateway to do this? Which, again, we could work around it, but it was a bit of it added friction to, we wanted to go fast as a dev team, and well, they wanted to go fast as a dev team, and we had to work with the ops team to make it happen. The third option, this is the kind of, greenfield, everything's kind of rosy situation. It literally is putting everything in the Kubernetes cluster. You're seeing this done quite a bit now. On, clouds often, like Amazon, offer their own API gateway as a service. Google, their own API gateway as a service. We do see a bunch of folks running Envoy-based gateways in kind of hosted Kubernetes clusters like EKS, AKS, GKE, that kind of thing, and just doing like load balancers to pass through, like a ELB or an ALB or something in Amazon world, passing through to the Kubernetes cluster. And again, we're in there, Ambassador, Glue, Contour, Trafic, we see that there quite a lot. The idea being that these are fully kind of Kubernetes native gateways. You can configure the WAF, you can configure the auth, you can configure everything using Kubernetes YAML. So the same deployment pipeline you use for deploying your services, you do exactly the same thing for configuring your gateway. Yeah, and increasingly, if folks are adopting things like service mesh, we see this as a very popular pattern because all your service mesh config is going in with the Kubernetes config, and now you're configuring the edge with the same patterns as well. The pros is, simplified edge stack, right? But this is very much a greenfield thing. It does support best practices like things like GitOps, where you have a single source of truth and there's no real potential for collisions with old world and new world. The cons are it's a large architectural shift. If you're an enterprise, this is going to take a while to get to. You're not going to do this overnight. And we have found that platform teams have to learn about new proxy technologies. We see a bunch of folks are super happy with Nginx, super happy with F5, and when they bring an Envoy-based proxy, which a lot of the modern proxies are based on, they have to learn about Envoy. Envoy is a fantastic piece of technology, as is Nginx, as is F5, but they're all subtly different. And Envoy is very much born of the cloud native world. So there's a few things, just catch folks out. They have to learn more about it. That needs to be sort of put into your plans as you're rolling out new gateways too. So let's wrap this up. That's been a whirlwind tour of kind of where we've come from in the load balancer API gateway space, some of the interesting things we've seen in the sort of microservice world, and some of the new challenges with things like Kubernetes and how they integrate with the old world. And we've seen some problems and some patterns on how, at the macro level, I've seen folks adopt and migrate towards an API gateway running in Kubernetes. Wrapping up, so the meta message I want folks to take away from this really is we definitely have seen an evolution at the edge space, and it's continuing now. New technology is coming out as we speak. The service mesh space, the API gateway space is super hot at the moment. And it's because it's a component that all of your traffic goes through. So you want to make sure you get the right decision. It's not something that's easy to remove once you've sort of put it in. We've definitely seen, in addition to being driven by architecture and tech over the years, we've definitely seen this move from hardware to software. We've seen a move from the networking at the layer 4 kind of IP address port type level to more towards layer 7. So your application level aware, you're looking at things like HTTP metadata to make routing decisions, you're looking at Mongo metadata, you're looking at Kafka metadata, you're looking at layer 7, the application layer of the communication, and making routing decisions based on this. We're also seeing the big thing of a move from centralized management to decentralized management. No longer is it kind of perhaps one ops team that does everything. The ops team might maintain the gateway, they might look after it, but they expose the interactions via a self-service mechanism, via an API, via a UI. No longer are you raising tickets and chatting necessarily to the ops team. It's much more about self-service. And this has largely been driven by adopting microservices. There are more things at the edge. We want to go faster. This is the beauty of microservices. If we get it right, we can independently release things, we can have different release cadences, and we can scale differently. When you get it right, I've seen it on a couple of projects, done really well. Microservices, as advertised, are fantastic. I've worked on a fair few projects where it's not gone well, I'll be honest. We've done distributed monoliths, we've done a bunch of other stuff, but as you move towards a microservices way of working, go into Kubernetes and so forth, you will notice there are more things at the edge. How do you scale the management of that? Again, it's all got to be self-service. The way I expose my routes, the way I configure my auth, the way I configure my caching, in whatever language I'm writing apps in, I need to be able to configure those cross-cutting concerns. You need to think about supporting multiple protocols, gRPC, gRPC web, HTTP, sort of at a higher level, things like GraphQL, increasingly popular now, a bunch of other cool technologies out there. We need to make sure our gateways support what we need. And the meta message really is choose your platform intentionally. As you're moving to this cloud native way of working, your workflow will change. If you're going sort of microservices and optimizing for fast feedback and so forth, but recognize that your platform probably has to change with that. I've talked about API gateways here, but you'll also need to think about this with your continuous delivery, your way you monitor, the way you observe systems. Fundamentally, it's been a hard lesson for me, to be honest, as a developer, as an ops person over the last 10 or so years. The cloud opens up a lot of possibilities, but we have to change our mental model. We have to change our tooling. We have to change the platforms we're deploying onto. And too many times I bump into folks like customers and people I work with where they're bringing the old ways of thinking and the old technologies into this new cloud world and not getting the full benefits, which is quite often a shame. A couple of parting words. I think the best thing to do around this, I wrote an article on the New Stack a couple of weeks ago now, talked about if you want to get involved with Kubernetes, you've got to get hands-on. If you want to play around with API gateways in this space, hands-on. There's things like Katacoda. We've got some stuff online as well. Lots of links in the New Stack article there. If you're learning Kubernetes as a Java developer, as an ops person, whatever your sort of background, hopefully that blog post or that article is useful for you. If you want to get started spinning up your own playground in Minikube or GKE or whatever, there's a free tool we've got at getambassador.io, or app. .getambassador.io. No registration required. Basically, it asks you a series of questions about how you've configured your Kubernetes cluster, what kind of observability you want in it. We've got like an Argo plugin for continuous delivery. Basically, you answer a bunch of questions on the website, and it will spit out some YAML that you can apply to your cluster, and you get a playground where you can deploy your apps into and start testing. So we'd love your feedback on that. I'm working on this quite a bit at the moment. Just trying to help our customers, or help folks in general, spin up a Kubernetes cluster, learn as fast as they can, and then get to production. So we'd love your feedback on that kind of thing. Finally, many thanks. If you want to know more about some of the things we've talked about, you can find additional details there. Building Kubernetes platform link with a bunch of podcasts with interesting folks like Kelsey Hightower, Katie Gamanji. I've chatted to so many people over the last few months. I've learned a bunch, and I've shared it, so hopefully you can listen to this and get the same value I've got as well. You can find my writings on InfoQ there. Find me in the DataWire Slack, on Twitter if you want to ask any questions. If there is any questions now, I'll take them. But feel free, I'm around on the interwebs. Just reach out to me. My DMs are open. My email is available most places. Happy to field questions. I can't guarantee how fast I'll get back to you, but I will always try my best. So at that moment, I'll say thanks, and we'll see if there's any questions.
Okay, thank you very much, Daniel, for the great session. No, I don't see any questions yet, but if someone wants to ask, I'll check it.
I appreciate it. It is quite a data dump, so don't worry if people were. The last time I did a very similar talk at DevOpsCon earlier in the year with the Ajax team, and it took a while for questions to roll in, and we came to the conclusion that there's quite a lot of information there.
Okay. No questions, just applause, and it's a great session. And thank you very much, Daniel.
Cool. Thanks a lot, Marius. Appreciate the help there.
Okay.
Thanks, everyone.